Alright, algebra review. When we solve for the variable, it's just like the numbers, So if I had 3x is equal to 6, I would divide that 3 off and get x is equal to 2. A lot of you guys know how to do this. When we get the variables, it's exactly the same. Anything that's attached with multiplication, you're going to divide off. Anything that's attached with addition, you're going to subtract off. There just happens to be a little more nastiness to the problem. So if we want x, we're going to divide that RT off. Alright, so x is equal to 3 over RT. The same way, if we want t, we're going to divide off XR. So we'll have 3 over XR. And if we wanted the R, we would divide off the X and the T. So we would have XT underneath. That's number one. Number two, I want B. I'm going to multiply both sides by 2. So I've got 2A is equal to BH. And then I want that H gone, so I'm going to divide both sides by H to get that final answer, 2A over H. For R, just dividing off that 2 pi, we'll get R all by itself. So I'll get R is equal to C over 2 pi. And again, 2 pi looks a little aggressive, but it's just a number. We divide it off. For P and A, the first step for both of these, I'm going to multiply by 2. So I get 2 big A is equal to little a times P. Alright? To solve for A, I would divide both sides by P. So 2A over P. To solve for little a, to solve for P rather, I would divide both sides by little a. So I get 2 big A over little a. Now this one, lots of fun. Multiply both sides by 2. Let's solve for H first. Multiply both sides by 2, and you'll get 2A is equal to H times B1 plus B2. Here's where it gets a little dicey. If you're solving for H, you simply divide B1, B2 on both sides. It'll cancel over here on the right, and then on the left, it'll even it out. So for H, it's just 2A over B1, B2. Let's take this, what we originally started with though, and now we can solve for B1, B2. So I've got 2A is equal to H, B1 plus B2. Now what I'm going to do is divide both sides by H. And what that does is release my B1, B2. So I've got 2A minus H is equal to B1 plus B2. If I want B1, I would subtract off B2 from that other part. You subtract both sides by B2. If I wanted B2, I would subtract B1 from both parts to get that. Onward, same thing here. First step is identical for D1 and D2. I multiply by 2 to get that 1/2 away. So I've got 2A is equal to D1 times D2. If I want D1, I divide the D2 off. If I want D2, I divide the D1 off. It's really that easy. It's really that easy. This one, H, we're just dividing both sides by B, and we'll get A over B. For Z, multiply both sides by 2. You'll get 2WXY for Z. So multiplying both sides by 2. On this one, I'm going to divide both sides, for W, divide both sides by XY. Now, when you get this, you've got 1 over 2. That Z could really go up here. This could really be Z over 2. And that will allow you to put the XY simply in your denominator. So I've got Z over 2. And then the X and the Y are also going to divide in. Last two, I want R. The first thing I'm going to do is divide by pi. So A over pi is going to be equal to R squared. Last step, take the square root of both sides. R is going to be equal to the square root of A over pi. This is what I would accept. If you have to rationalize this, you've got a pi in there. So rationalizing it is a bit of a stretch. But if you were to rationalize this, you would get square root of A pi over pi to not have a radical in the denominator. But I mean, seriously, you've got a pi in the denominator anyway. So would you need to do that? Not sure. Ask your teacher on that one, whether or not they're going to have you do that. This one over here, we've got a y. We'll divide by tu to get that y alone. We've got g over tu. And that'll be this first page. Let's see if we can't get this second page done real fast. To solve for y, this is just like linear equations. On the first one, I'm just going to subtract 5x from both sides, and we'll get negative 5x plus 8. Casual thought, I'm going to try to hold those x's right by the equal sign, just like I would in linear equations. This next one, again, it's a fractional x, but it doesn't matter. I'm still going to subtract it from both sides. My next one, I'm going to have to do some stuff after I move that x to the other side. So I've got negative 4y is equal to negative 3x plus 12. Divide both sides by negative 4, and that's going to give me 3 over 4x rather, minus 3. On this one, subtract that 1/2 x from both sides. I'm going to get negative 2y is equal to negative 1/2 x plus 4. Divide both sides by negative 2. So 1/2 divided by 2 is going to give me 1/4 x minus 2. On this one, two ways to do it. I would multiply everything by 2 and change it to a fraction. And the only reason I'm doing that is I like it better that way. It's really lots of different ways to do this. I do it so I don't have those decimals. I can get the fractions that I'm used to seeing with linear equations. All kinds of reasons for me. You do not have to do it that way. But for me, it just makes more sense. So I'm going to get 1/2 x plus 4 once I shake all that out. Number 16, pull that 4x from both sides. I'm going to get negative 2y is equal to negative 4x plus 9. Divide everything by negative 2. And I will get y is equal to, I've already got the y is equal to, 2x minus 9 over 2. You can put 4.5, which is what I'm going to do. 9 over 2, also acceptable. Number 11, first step, pull that 5x from both sides. I will get 11y is equal to negative 5x minus 3. Divide both sides by 11. And I will get y is equal to negative 5 over 11x minus 3 over 11. You can shoot those as a decimal if you want to, but I do not want to mess with that decimal, so I'm going to leave it alone. On my next one, same thing as last time. You know what? I'll do it as my final step here because 1/3 is not so bad. So I'm going to minus that 3 over 4x. I've got 1 over 3y is equal to negative 3 over 4x plus 6. Multiply the entire thing by 3, and I'll get y is equal to negative 9 over 4x plus 18. Onward. Combine my y's up. I've got negative 2y plus 6 is equal to 9. Pull that 6x from both sides. I will get negative 2y equals negative 6x plus 9. Divide everything by negative 2. And I will get y is equal to 3x minus 4.5. My last one. Pull that 2x from both sides. I'll get 4y is equal to negative 2x plus 12. Divide the 4 off. And I will get 1/2 x. It'll be negative plus 3. That'll be my last one. Looks pretty good. Make sure that you watch your positive and negative and take care of fractions in a manner that allows you to be accurate. That's the most important thing on this one. You're going to get fractions, you're going to get decimals, you're going to want to be accurate. Use a method that allows you to do so.